Okay, lesson 30B, we are continuing proportional relationships with equations like we did yesterday. We're using different variables and figuring out which one replaces the y, which one replaces the x. But we're going to think of it more as unit rate today and then read those answers appropriately. Starting with some background knowledge, we have the vocabulary phrase unit rate, which is old news, right? We all know what this is. It's a rate that compares two different things, and it has to be compared to one, like miles per hour or dollars per gallon. It's all per 1 mile or per 1 gallon, per one book. And you have to divide to simplify. So for example, we have this rate given to us, words in minutes. So with those two numbers, all you have to do is divide those numbers. I'm just going to do it for you really quickly. That would be 63. And then with the label, it will be 63 words per 1 minute, making that a unit rate. Unit meaning one, right? Then miles and gallons, those are two different things. So comparing those, you have to divide to simplify. And this gives you 36 miles per 1 gallon. Everyone okay with unit rate, right? All right. So write this down on your notes again. This is proportional relationships have equations in the form. Do you remember from yesterday? What was it? Y equals, Aiden? Good. Y equals kx. Y equals kx. Y equals whatever your constant was, x. Now I left you some space to write down these examples. Please write all of them down. Y equals 7x is proportional. Y equals 4 over 1x is proportional. Y equals 2/3 x, that's proportional. Y equals 5.2x is also proportional. Fractions and decimals are okay, that's just your constant. Okay? Now these examples are not proportional. Y equals 7x plus 3. Y equals x minus 2. Y equals 2/3 x minus 5. Y equals 5.2x plus 7. Write down that list. Now I want you to think in your head to yourself, don't say it out loud, what's the difference between these two lists? Why is this first list proportional, but the second list is not proportional? Just think it in your head first. There's a difference between these two lists, and it's very, very obvious that this one has it and that one doesn't, or something like that. Now turn to your neighbor and tell them what that is. Ready? Share. Go ahead.
Something is being added or subtracted to x.
Good. In the not examples list, there is something being added or subtracted to our x term, right? This first one, this is all in the form y equals kx. This one is not. This is y equals kx and then plus something or minus something. So that's not proportional. So they all have this little extra piece at the end, right? You see that? In 8th grade, you're going to learn that that's called initial value. Right now, we don't have to worry about that. Just know that it's not in the form y equals kx because there's that extra piece at the end. So, going on to your official number 1 on your notes, we want to find unit rate. This is old news. You know how to do this. So I'm just going to quickly do the math for you. You would divide this. 84 divided by 5 is obviously 21, right? So since it's asking for unit rate, you do have to label it pieces per minute. And unit rate without the label is called what?
Rate.
Not quite. Starts with a K or a C.
It's the
Constant. It's the constant of proportionality. So the constant would be just the number part. The numerical value is 21. I'm going to put that exact same problem into a word problem, which is what we're focusing on today. A machine that wraps candy can wrap a total of 84 pieces in 4 minutes. Write an equation that shows how many pieces of candy P it can wrap in X number of minutes. So this part we already did. 84 pieces in 4 minutes. That's what? As a unit rate? 21. And it says to write an equation. We know the equation is y equals kx. I'm going to start with that. And I already found k. So I'm going to replace k with 21. But now this word problem says I have to use the variables p and x. we know that unit rate is always like this ratio, right? Y per x, y over x. So in this case, pieces per minute, right? Like our unit rate up there says. If it's pieces per minute, or y per x, which one is the p replacing the y or the x? It's replacing the y. So my equation is now going to be p equals 21x. The x is just going to stay the same because it said we can still use the same variable. Okay, any questions about this so far? All right, let's try number 3. Same thing, we want to find the unit rate first. $300 for 8 hours. $300 for 8 hours. You would divide it and you get $37.50 per hour. This is our unit rate. What is the constant? Meaning, what is the numerical value with no label? 37.5. Good, 37.5. Constant is 37.5. Let's put this exact problem into a word problem now. Michael is working 8 hours per week while working as a lab tech and earns $300 for each week of work. Write an equation that represents how much money M he earns per hour H. So instead of using X and Y, I have to use M and H. Now I have to think which one is replacing which one. So we already know it's going to be Y equals KX. We already figured out what K is, so let's plug that in, 37.5. Now I need to know, is it M equals or H equals? So you think about this. Are they asking for money per hour or hours per money? Money per hour, and that last sentence tells you that, M per H. So we're used to Y's per X. So what's your new equation going to look like? Excellent. M equals 37.5 H. Again, we're used to Y equals KX, which is Y's per X, right? Miles per hour. Y over X is our ratio. So if this time they want us to use M per H, that means M was in the place of Y, and X is in the place of X. H is in the place of X. Let's do number 5. Find unit rate of miles per gallon. Grace, what would that unit rate be? You should get 35 miles per gallon, which means K equals 35. Good. And I'm going to put that exact thing into a word problem. Sam's new hybrid car has a gas tank that holds 12 gallons of gas. When the gas tank is full, he can drive 420 miles. Write an equation that represents how many miles Q his car gets per gallon W. So again, we know it's Y equals KX. We know K is 35. Now I just have to think, does the Q replace the Y or does Q replace the X? Is it asking us miles per gallon or gallons per mile? Carlos? Miles per gallon, which we're used to Y over X. So we want Q's per W or W's per Q?
Q for Y.
Q equals or W equals?
Q equals.
Good. Q equals. So Q equals 35, W is your new equation. Any questions? All right, turn your notes over. I would like you to do number 7, 8, and 9 on your own. There's no lead-in problem this time. I just went straight to word problem. So first thing you need to do is find unit rate so you know what K is, and then replace it with the variables that it tells you to. Then we'll share. So let's go over number 7. Who wants to share what they got for that one? Thank you.
I got C equals 350B.
C equals 350B. Who raised your hand if you got the same thing? Good, I walked around and saw everyone got that one right. Very nice. Number 8. Go ahead and share what you got for that one.
I got
M equals 5h. When you divide, some of you, I saw you forgot to do this. This decimal moves because you're multiplying both numbers by 10, and then the decimal looks like it disappears. So your constant should not have a decimal in it anymore. Okay? Number 9. Thank you.
I got C equals 9p.
C equals 9p is correct. Who got all 3 of those correct? This side's looking good. What happened, you guys? Messed up on number 8, huh? All right. Number 10 is fractions. Should not scare you. We've been doing this in our homework for the past, 4 months. So 1/3 miles and 1/5 in an hour of an hour. You're doing the same thing. Divide those. Dividing fractions is multiplying by the reciprocal, or if some of you like to say keep, change, flip. So go ahead and do this one with me. This would be 1/3 divided by 1/5, which is 1/3 times 5/1, the reciprocal, which gives you 5/3. And I do have m equals 1 2/3 h here, but I want you to write this on your notes. Leave it as an improper fraction, because when we move into doing more of these on graphs, that improper fraction is going to make a little bit more sense, it'd be more helpful for you. So go ahead and write both answers. We like the 5/3 better. The 1 2/3 is correct, just looks kind of funny. Okay? Do number 11 by yourself, please. Perfect. G equals 1 1/3 W, or as an improper fraction, which is preferable, G equals 4/3 W. So far, so good? Go ahead and finish the rest of your notes by yourself. 12 through 17 is basically a summary of everything we just talked about. And I want to see if you can answer those questions by yourself. So again, do 12 through 17, please. Number 12, is this proportional? No. Who can tell me why? Yes, sir.
Because something is being added to the value of x.
Exactly. There's something being added to the end of it. We just want y equals kx, not y equals kx plus something. So it's not in the form. Number 13, yes or no?
Yes.
Yes. How do you know?
X is all by itself as an individual.
Exactly. This is y equals kx. K is whatever your constant number is, and there's nothing else at the end. So this one is correct. Number 14, is that proportional?
Yes, it's proportional because there's nothing being added to it. It's just one.
Good. It's in the form y equals kx. There's nothing hanging off at the end. Last one? Dominic, tell me yes or no. How do you know?
Because there's something being added to it.
Good, because there's something added or subtracted to the end of it. All right, and did everyone get this one right? I mean, all these correct? Looks like you did. Very good. Last two, I just wanted some examples. So go ahead and raise your hand and share those. Yeah.
Y equals 7x.
Y equals 7x. That is proportional. What's another one? Yeah?
Y equals 1/5 x.
Y equals 1/5 x. That works as well. Chloe, give me one.
Y equals 9 -
Say it again. Y equals 9 minus 2.7. It should be y equals, oh no, still proportional. 10x, okay, that works. Y equals 10x. Give me one more. Natalie. Okay, those are all very nice. How about equations that are not proportional, Noah? Y equals 22x plus 22. Okay. Scott?
Y equals 1/3x
Minus 7. Good. How about Cicely? Say it again. Plus 7x. All right, very nice. One more. Amy. Good. These are all examples that are not proportional because of that extra plus or minus something at the end. All right, any questions about today's lesson? Great. Number ones, will you please share first what you learned today? Ready? Share.